Hi guys, welcome to the first edition of the Science Chef Educational Series on Chemistry for the year 2021. In this video, we will be learning about an interesting concept of chemistry called oxidation numbers. So tighten your seatbelts, relax, and enjoy the ride, as we'll be right back after this break. For your group of private online tutorial classes on any or all of physics, chemistry, biology, and mathematics, you can talk to us via any of our contact details showing on the screen or in the description below, and you'll be glad you did. Welcome back. Oxidation number is the charge an element possesses in a radical or ion. In other words, it is the charge that arises when the two electrons in a covalent bond are assigned to the more electronegative atom. For example, in a hydrogen chloride molecule, if the pair of electrons used in forming the bond between hydrogen and chlorine is assigned to the more electronegative chlorine atom, it will have a charge or oxidation number of -1, while hydrogen will have a charge or oxidation number of +1. It is also the charge an element possesses in an ionic bond. For instance, in potassium bromide, potassium has a charge or oxidation number of +1, and bromine has a charge or oxidation number of -1. So, if you want to learn everything about oxidation numbers, watch this video to the end, like it, and subscribe to our channel. Now, let's consider the rules for determining oxidation numbers. Note that these rules are arbitrary and do not follow any specific order. Rule number 1. The oxidation number of any element in its free or uncombined state is 0. For example, oxygen, hydrogen, and iron are all in their free states. They are standing alone or uncombined with other elements, so the oxidation number is 0. Rule number 2. The oxidation number of oxygen is -2 in all compounds. Take note, in all compounds, except in peroxides, where it is -1. A peroxide is a compound that contains the peroxide ion. It has one oxygen atom more than its corresponding oxide. Examples are barium peroxide, hydrogen peroxide, and sodium peroxide. Rule number 3. The oxidation number of hydrogen is +1 in all compounds. I repeat, the oxidation number of hydrogen is +1 in all compounds except in metallic hydrides, where it is -1. Metallic hydrides are compounds formed when hydrogen combines with metals. Examples are calcium hydride, sodium hydride, and lithium tetrahydridoaluminate 3. In the presence of these metals, hydrogen acts as a typical non-metal and gains electrons to form hydride ion. Rule number 4. The oxidation number of a simple ion, that is an ion that contains only one atom, is equal to the charge on the ion. As shown on the screen, ion 2 ion, chloride ion, potassium ion are simple ions that contain only one atom of the element. So the oxidation numbers equal their charges: +2 for ion in ion 2, -1 for chlorine in chloride ion, and +1 for potassium in potassium ion. Rule number 5. In a neutral compound, the aggregate sum of the oxidation numbers of all the elements present in the compound is equal to 0. In the examples on the screen, the sum of the oxidation numbers of sodium, oxygen, and hydrogen in sodium hydroxide equal to 0, the neutral charge on the compound. Same is applicable to other compounds. Rule number 6. In a polyatomic ion or radical, the aggregate sum of the oxidation numbers of all the elements present is equal to the charge on the ion. From my examples, the sum of the oxidation numbers of the carbon and 3 atoms of oxygen in CO3 2- is equal to -2, the charge on the ion. This concept is applicable to the other radicals. Let's see how to apply these rules by calculating the oxidation numbers of the underlined elements in the molecules and ions showing on the screen. In the first example, ozone is an allotrope of oxygen in an uncombined state. Hence, the oxidation number of oxygen in ozone is 0. That's according to rule 1. In the second example, we will make use of a combination of rules 2 and 5. Firstly, carbon dioxide is a neutral compound. Therefore, the aggregate sum of the oxidation numbers of carbon and the 2 oxygen atoms will be equal to 0. Secondly, the oxidation number of oxygen is -2 since it is not a peroxide. So using these pieces of information, if we solve for the oxidation number of carbon, we get +4. In our third example, we will apply rule 4. The sulfide ion is a simple ion. Therefore, the oxidation number of sulfur on the ion is equivalent to the charge on the ion, which is -2. In example 4, we will combine rules 2, 4, and 5 to find the oxidation number of manganese as follows. According to rule 5, the aggregate sum of the oxidation numbers of potassium, manganese, and the 4 atoms of oxygen will be equal to 0, since MnO4 is a neutral compound. From rules 4 and 2, the oxidation of potassium is +1, since it is a group 1 element, while that of oxygen is -2, because the compound is not a peroxide. Therefore, using these parameters, we will find the oxidation number of manganese to be +7. In example 5, Cr2O72- is a polyatomic ion or a radical. So we will make use of rules 2 and 6. From rule 6, the aggregate sum of the oxidation numbers of the 2 atoms of chromium and 7 atoms of oxygen will be equal to -2, the charge on the ion. Also, since the ion is not a peroxide, then the oxidation number of oxygen is -2. Hence, solving for chromium, we get +6 as its oxidation number in Cr2O72-. In example 6, we will make use of rules 3, 4, and 5 to determine the oxidation number of aluminium. Since you now understand how rules 4 and 5 apply here, I will only explain the application of rule 3. LiAlH4 is a metallic hydride. Since both lithium and aluminium are metals, hence hydrogen has an oxidation number of -1. So if we use these parameters to solve for the oxidation number of aluminium, we get +3. And lastly, in H2O2, we apply rules 3 and 5 to determine the oxidation number of oxygen. Since it is not a metallic hydride, the oxidation number of hydrogen is +1, and solving for oxygen, we obtain -1 as its oxidation state. This is absolutely correct because the compound is hydrogen peroxide, which is a peroxide. Note that in our solutions, all the answers are accompanied by signs, either positive or negative. This is because oxidation number is not just a number, but a charge. So you are wrong when you fail to add the appropriate sign to the oxidation number of an element. Finally, let's look at the importance of oxidation numbers. Firstly, the concept of oxidation numbers can be used to describe oxidation-reduction reactions, otherwise known as redox reactions, such that it can be used to identify the oxidizing and reducing agents and the substance that is oxidized or reduced in a redox reaction. You will have to watch our video on oxidizing and reducing agents in redox reactions to have a better understanding of this. You can click on the link in the description below or its thumbnail at the end of the video. Secondly, the concept of oxidation numbers is applied in balancing redox equations. Our next tutorial video will be on balancing redox equations. So subscribe to this channel and turn on the notification bell to get notified when the video is published. Lastly, we make use of the concept of oxidation numbers in the IUPAC nomenclature of compounds, especially in organic compounds. For instance, carbon monoxide CO and carbon dioxide CO2 are named as carbon 2 oxide and carbon 4 oxide respectively. The 2 and 4 are the different oxidation states or oxidation numbers of carbon in the 2 compounds. So if you enjoyed this lesson, like and share this video. Follow us on our social media platforms. Thanks for watching and stay safe.